Okay, good morning, ladies and gentlemen. Okay, if you could do this number 7 here, we'll find the critical numbers.
Do you have to use quotient rule?
That's what I would do.
You're killing me, Mr.
What's the quotient rule?
That's what I
Are you
would do.
dying?
Lucky.
Uh-huh.
We never know about quotient.
Low D high times high D low, all over those squared?
Minus high D low.
Minus high D low.
You have to do the song. Lodi, 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 high.
Yes?
Minus high D low.
Oh,
Minus high
D high.
all over low squared.
All over x minus 1 squared.
Yeah, I was asking what it is.
So we have high.
So that's just that. And so how do you find those critical numbers? Ah, I got it.
That's good.
So we have
Carson, this is Yaku.
Lodi high.
Me and this kid are gonna be best friends.
Lodi high minus high
Oh, you're my best friend.
D low. So you're going to have, for this one, you're going to have x minus x. So you're going to have negative 1. Is that what you got? Over x minus 1 squared.
What are we supposed to be doing?
And so, how do you find your critical number here? What is your critical number?
When the denominator is 0.
So your critical number,
Doesn't exist.
there's a critical number. What is a critical number?
If I remember, one.
Critical number is 1, x equals 1.
Right.
And then find increasing, decreasing, well, like this, right? 1, we have f prime, f. So if we take a number, well, that's always going to be f, that's always going to be, f prime is always going to be negative, right?
Oh, yes.
Yeah, so that's going to be negative, negative. So the thing's going to be going like,
It's gonna go.
like this, this. Does that make sense?
Yes.
Should. Okay, now, you remember what this, now, let's just go ahead and finish by sketching this thing. No, we're going to go ahead, so where do we say f of x is decreasing?
Everywhere except x equals 1.
Negative and b.
And,
1.
yeah, so what we do, and so I think Kylie said it right, and Aaron said it pretty much right too. So you're increasing on, and also you're increasing, decreasing again from 1 to infinity. And so you know what? And you know that because what? F prime of x is less than 0. So as far as the sketch of the graph of this, do we have a good idea from what this is about?
I think it would do like.
And what would be?
this, that.
So the things we can see maybe are maybe x-intercept, a y-intercept, a vertical asymptote, a horizontal asymptote. Do we have a horizontal asymptote for this?
I forgot how to do that. Did we ever learn how to do that?
Yes, we did.
Horizontal?
We did it this
It was called three things that start with B.
Oh.
Betsy, Bobo, Bo2.
Yeah.
Is this,
Zero on bottom.
Yo, guess who remembers that?
is
That was like
this,
the first thing we learned.
yeah, this is a while, right? So is this a Betsy or a Bobo or a Bo2?
But Betsy,
Oh.
Zero on bottom. Bob.
It's Betsy.
It is a Betsy, and so what is our
Negative
horizontal
one.
asymptote?
-1.
I'm thinking
No, just
positive.
positive one, shoot.
It's a
One,
positive 1.
positive one.
And what is our vertical asymptote?
Zero, or one.
1, right?
So it's 1, 1.
So there's our vertical asymptote, x equals 1, horizontal asymptote, y equals 1. And so we are decreasing from negative infinity to 1. So what is that going to, here's our asymptote. So things are going to go like this, right? And what is our y-intercept? We should have a y-intercept.
It's 0.
It's at 0? Yeah, because if we set this equal to 0, yeah, so it should be right at the origin. And then we have right over here like this. So the thing decreases here, vertical asymptote, then comes up from, so that's what the thing looks like. Curve sketching. Okay, we're going to go to note card 28. Yeah, and
Concavity.
we're going to talk about concavity today
Second
and work some
derivative.
problem, which is, yes, second derivative. And one thing I did at my other school was, that is hard to do here, and I'll show one thing we did at my other school before I came here, is we had a road outside the school. It was called Langdon Road, and it had more relief than we have here. It was more of a hill. And this is kind of what Langdon Road looked like, is you had like a railroad crossing and a creek bed down here, and then from there would come up to a hill like this, and then it would come up like this and gradually level out. And the school was right up here, so we'd actually go for a walk.
A walk.
We'd go for a walk, That was like the project, go walk, let's see what's happening. And what happened was that when we walked, we would take a walk from here and we would analyze if the road is increasing and is getting steeper and steeper and steeper. And obviously the elevation was increasing all the way from this point all the way up to here, right? But when was the hill getting less steeper as we went?
Like right there-ish.
Yeah, right about here. Okay. So this is an important little thing in calculus that we haven't talked about before now. It is called an inflection point. And I first noticed this when I used to do some long distance running, and after I get a hip replacement, I'm going to do long distance running again. Anybody ever do long distance running here?
No, but I think we're gonna.
Little
see
bit,
the
Hannah?
announcement.
A little bit?
Not like cross, like not like as a sport, like just done it.
Yeah, I done, okay.
You just run for.
Well, what I noticed when I was running before is that when you're running up a hill, you notice you're running up a hill and say, my gosh, that hill's getting steeper and steeper and steeper. And then about halfway up the hill, you say, oh, now it's not as steep anymore. And gradually the steepness decreases when you get to the top of the hill. And quite often you're gonna actually go down to another valley, right?
Yeah, that's when I start falling.
Yeah. And so this inflection point is where the steepness will change from increasing to decreasing. Okay, so that's graphically, physically, what is happening with an inflection point. And if you break this into two separate pieces, like this left piece over here, okay, thank you. Okay, thanks. Thanks, Jake. Okay, right here, what do you notice about this curve?
That curve,
It's starts off, so you can get steeper.
Okay, this piece here is what we call concave up.
Concave up? You can
Okay.
concave up?
Concave up.
Like you're talking about the fact that it's like, instead of,
Right, and Carson for
Oh.
concave up, right? And so one way you can look at this is you can consider this graphically as kind of a smiley face.
A smiley face is a concave up?
Yeah, it's a smiley, right?
or if you looked at like a ramp, it's like you're going like, on that, you're like, going
Yeah.
up to the ramp if you wanted to, I guess.
Yeah, So Carson's making some good suggestions, but there are a lot of different ways you can conceptualize what this is, right? So, and then we have this piece over here. This piece over here, we call this concave down,
I knew it.
okay?
I thought it was concave backwards.
I said it was saying, I was like, no, so.
Backwards.
And this is, would be what we call a frowny face, maybe. Okay, so that's just a conceptualization graphically of what's happening here. And
Pretty sure.
what we have, and look at the definitions, number one, concave up if f of x is increasing at an increasing rate. Do you see that? Increasing, but increasing rate. Increasing, 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 increasing rate. And then we are increasing at a decreasing rate as concave down. And likewise, you can have concavity over a decreasing interval as well. If we go the opposite direction and we go a hill that goes like this, it's the same thing, right? If we are decreasing at an increasing rate, we have concave down here. And then if we are decreasing at a decreasing rate, let's see, or decreasing at an increasing rate, we're concave up. So we're decreasing at an increasing rate. Anyway, that's what it'll look like. And so here's a concavity test for a function whose second derivative exists, so the second derivative has to exist. If f double prime is greater than 0, then y, the function, is concave up or above the tangent line. So here, if we make a tangent line right here to this curve, which I'm trying to do with this red line, right? The graph is above, lies above. And then if we draw a line here like this, the curve will be below the tangent line. So there's some different ways of looking at that. So we're going to work some exercises in that, and this really comes into we bring out a number line analysis, and I've introduced this a little bit up until now, but this is where we really sink our teeth into it. Okay, for the graphs of 1 and 2 below, determine the intervals where f is concave up and justify. And here we have two graphs, one of which is, this one is y equals f prime of x, and this one here is y equals f double prime of x. So I want you to look at that and think of it for a minute. One thing that could help you on this is number lines. So I want you to go as a sketch a number line, try to play around with this a little bit. I'll go over this with you in about 3 minutes.
Oh, wait, I think I did it.
Okay, let's go. Yeah, and one thing that's going to be helpful with this is something I introduced earlier, if it was earlier last week, is this thing right here. This F prime, F double prime thing. Remember that?
Yeah.
So we have plus, minus, increasing, decreasing. So plus, minus.
Ma'am.
Okay, let's go over this. Here we have F prime of X, right? And so what I'm going to do is, we're interested in concavity. So what I'm going to do is I'm going to put F double prime up here and just F down here. So for F double prime to F, what would be our critical numbers here for this?
What's that? Negative 1,
-3.
negative 3.
Well, -3, maybe not necessarily, that's sort of the edge, right? But -1, definitely, right? What else?
Positive 3.
1 and 3. Okay, now, why do we call these the critical numbers in this instance? Because obviously, if we're talking about a regular critical number, we'd be talking about, well, let's go look at the graph. F double prime. Okay, where do we see F double prime being negative? Where F prime is decreasing, right? So F double prime is negative because F prime is decreasing.
We require a person, and you have to have your mask, your picture.
Okay,
Then yes.
okay. Okay, now, so we have this right here, and then we're increasing here. So that's concave up, concave down, and then we have, finally, concave up here, which is going to look like this. So these curves are what the underlying function f is going to look like, okay, with the way the thing is curving. So we say, where is this function concave up and justify? Where do we see this thing concave up?
Between negative 1 and 1.
Yeah, so concave up on -1 to 1, and also,
3 and 3.
yeah, 3, well,
3 to 5.
3 to 5. We'll say 5 is the limit here, right? And justify because what? We're given the evidence of f prime, so f prime of x is doing what in these intervals?
Increasing.
Yeah, increasing. See, that's what this chart comes in, is increasing over those intervals. Now, when I gave you time to work on this, did anybody get anything close to that,
Yeah, I couldn't.
kind of? Well, you have these numbers, right, Kylie?
Yeah.
Pretty much. Okay, let's go look at problem 2 here. So here you have f double prime. So to me, this one is going to be even easier. And so what are the critical numbers in this instance?
Well, A and B and C and D. I don't know.
Okay, we are interested in where, and down here. So we're not looking up here anymore. We're looking down here at this third row.
Aha!
What would the critical numbers be down here in the third row? What? How do you identify a critical number based on this in the third row?
If it's above the x-axis.
No, it's where these signs change.
Yes. So yeah, like where it's 0.
Yeah, where the signs change. So where do we see that happen here? At 0? Where else?
C.
At C. And we don't know, we don't see after that, but I'll just put D just in case. So these will be the things we're going to be looking at here. And what do we have between A and 0? That's going to be F double prime.
We have this decreasing,
No, it's negative.
negative.
And so we're going to have concave down over that interval.
Mhm.
And between 0 and B, well, actually between 0 and C, what do we have here? Positive, right? So concave up. And then between C and D, concave down. So then we're asked to answer the question that we answer for number 1. So we say we're concave, concave down. Okay, we're concave down on which intervals?
Concave down between
On
A and 0
A to 0,
and C to D.
A to 0, and C to D, because what? F double prime of X is doing what?
It's below 0.
It's less than 0. Okay, so here, do you see between these two we use different pieces of evidence? On this one here, the evidence was, is the graph below or above the x-axis, and does the change, right? And then over here, on the left one, it's going to be where f prime of x is increasing and where f prime of x is decreasing. And so we're having to analyze using what I call different dimensions of the same original function. So let's go over here and see what we have. So now we have a table with key values here, and we're told that the function is continuous. Now, if we were not told somehow that the function was continuous, could we tell the function was continuous from the data?
What was the question?
Could we tell, just looking at that table, if if that represents a continuous function?
Yes.
No, we can't, because these are just points, right? These are just snapshots at a point, and so they have to tell us, okay, they have to give us information to let us know this is a continuous function. So I want you to go ahead, determine the intervals for which f is concave up and concave down, and determine, if you can, where the concavity changes, and justify that. So see if you can justify that. Yeah, justify. We're given f prime in F. My way of looking at this would be to construct a number line, use that number line to analyze kind of where you are. Okay. What do you have for this?
Are critical numbers -1 and 1?
So -1 and 1 are your critical numbers?
I think so, that's correct.
Well, the thing about it is we don't see between -1 and 0, right? But we know the function's continuous up to 0. So we can't really see 100% what's going on in this thing here, and it doesn't really tell us if there are any other changes here. But what do you notice about what is F prime doing here? F prime is doing what? Increasing or decreasing? Increasing, right? And what's going over here? F prime is decreasing. So it looks like 0, we see undefined here, that's going to be, for purposes, critical number. And so if we have F prime increasing, what is F double prime doing?
If F prime is increasing,
F double prime is what? Okay, get a little chart here. Here's F, F prime, F double prime. So you have plus, minus, and then we have concave up, concave down. So here in F prime we have plus, minus, increasing, decreasing, and then plus, minus down here. Okay, if F prime is increasing, what is F double prime doing?
It's positive.
That's positive, right? And then, what is the underlying function doing underneath it? Concave up. Okay, in this interval here, what's F prime doing?
It's decreasing.
Decreasing, so what is F double prime here? What's associated with decreasing?
Negative.
Negative. So we have concave down. So you see how all these are linked in? How all these are linked together? And so determine intervals A for which concave up. So we'll say A, we say F of X is concave up on which interval? On which interval are we concave up here? -3 to 0. Now, I'm not 100% sure about going all the way to 0, but based on the function, based on where the function is going, and just kind of extrapolating what it looks like it's probably doing, we'd have to just justify that and say, and that's going to be because what? Because F prime is doing what? Is increasing. And then B, F is, so it's similar here. F is decreasing, or concave down, excuse me. F is concave down on 0 to 3 because F prime is decreasing. And then it says determine the X value, if any, where the concavity changes. Well, as far as we can tell, that's going to be 0, right? To be more fully accurate, they could have done some more explanation about that here, but this is the best we can get out of it. So that is that problem. So my suggestion is to drag out the number lines.
I'm sorry, my manager texted
You have to work tonight?
me. Yeah, Cora's coming, so she's texting.
Okay.
She said Cora's coming.
Where y'all closing again?
Well, if you fail right now, but if you don't fail,
Okay.
you have to go fail.
Now we get to know car 29, and we'll just sort of, we learn about two things here. We're learning about something called a POI, point of inflection, and a PPOI. If a POI is a point of inflection, what's a PPOI going to be? Okay, PPOI, it's a potential point of inflection or a possible point of inflection. And so what you're going to do is you're going to find where f double prime equals 0 with the second derivative, and then do a number line test to see if the signs change. And if the signs, and what happens when you put the 0 on the number line, that's a PPOI. What happens when the sign changes? Signs change. That actually becomes a POI, a point of inflection. So PPOIs, POI. So I'm going to ask you that tomorrow when you come to class. So let's go here and look at these ones. So I want you to work out this problem right here and see where this is concave down. We'll talk about that, and that's probably where we get to today. So go ahead and do this one. What are you going to be doing first here?
You can find double prime.
Find the double prime, right? So here we have this thing here. I don't know, 48 is not it, maybe 12 is it, right? That's going to be minus 8x plus 4, is that right? So what is this one going to be? 12, negative 8. What two numbers are we talking about here? 2 and 6? Negative 2 and negative 6? Divide by 3. So we get negative 2. So we get x minus 2/3, x minus 2. So that's going to be 3x minus 2, x minus 2. And so that's going to be 12 on the outside. We set that equal to 0. So we have x equals 2/3 and x equals 2. And then we go ahead and set our set our number line, 2/3 2, and here we put y double prime, and then y goes down here. What do we have over here to the left of 2/3? We have positive. Okay, so there's a concave up, and between 2/3 and 2, negative, and greater than 2 we have positive. So where the graph is concave down for which intervals? Graph of y is concave down on which interval?
Between 2/3 and 2.
On 2/3, comma 2, because f double prime
Double prime
is less than 0. Okay? So really that's it. So we're going to be doing a lot more analysis like this. It becomes part of our box of analysis tools on this.